Shanny, and today in Homemade Science, I thought I'd share with my educator friends some really basic equipment that I found helpful in my classroom. It's these wooden blocks.
Each set consists of 5 blocks. They are 5.5 inches long and will cut out of a 2x4. 2 of the blocks have eye hooks recessed into the side of it, and rubber bands can be attached to those eye hooks. This block has dowels attached to each side of it. That way we can add additional blocks and strap them in place.
So what do I use these for? Well, I can do demonstrations with them, or I can have students investigate for themselves. We can look at Newton's laws of motion, momentum. We can also use them for demonstrating friction. All right, now let's start with Newton's first law, which is actually Galileo's idea of inertia.
If pulled slowly, the top block will move with the block it's sitting on. When I accelerate the blocks quickly, the resistance to changing its motion leaves that top block behind. Inertia depends on the amount of mass in the blocks, and in this case, whether the blocks move or not depends on the amount of friction between the moving block and the one sitting on top of it. Reducing the friction between the bottom blocks means the bottom block doesn't have to move as fast. Even banded together, we can see this resistance to change. Watch it in slow motion. To show this part, we're going to add a small block to the back end of that 2x4 piece. We'll simply tape it in place. It's going to have a lip on the back side of it, which is going to allow it to push the block on top of it forward. In this case, when the bottom block stops, the top block continues to move forward until friction slows down and stops it. We'll start with the same blocks and the same rubber bands. The blocks will accelerate together. Part of our discussion does include that the force is not constant as the rubber band recoils. If we increase the mass on one of the blocks, we'll find its acceleration will be slightly less. The additional mass will also increase the amount of friction slightly, but we'll talk about that later. Here's triple the mass. Let's go back to the same mass, but double the rubber bands and see how that affects it.
That one has double the terms of force that one has.
Okay, good.
Now the next step is to double the mass on the double rubber band. See how they compare. It looks like they accelerate about the same. As we stretch a rubber band, the force is constantly changing, but the scales show us that the force is always equal in opposite directions. So even as the amount of force changes, each block is always feeling the same amount of force as the opposite block.
Try this again. I stretch them out 1 meter. Where should they meet?
In the middle of the meter stick.
In the middle. Okay. Well, let's see if that's right.
This will
3,
go.
2, 1. I've doubled the mass on this one. Stretch it out. Which ones feel it? Which one's getting more force?
They're equal.
Which one's getting more force?
Equal.
3, 2, 1. They met about here.
The force is always the same on both blocks, but as we increase the mass on the one side, it decreases the distance that it moves.
Now another area that I use these blocks for is a basic demonstration of friction.
Students have a lab activity where they measure how friction affects various surfaces. After completing the lab, I can then go over the results on a larger scale using the blocks. One suggestion is to use furniture polish on the table before using it to let the blocks slide easier.
Now another possibility is to add some wheels to the blocks.
Simple plastic wheels nailed into the sides of the blocks can improve the performance as it decreases the amount of friction. Comparing the blocks with wheels versus without wheels, we find the position of impact differs by about 5 centimeters. So it's not a big change in our results, but when I use the blocks without the wheels, friction is part of the discussion.
Now if you're worried about students pinching your hands between the blocks, or you simply want to go larger, you can do all the same demonstrations using cardboard boxes. And it's also very easy to change the mass. Just simply put something inside the box. Now one more use for these blocks is to turn them into a game.
We came up with a couple different games of inertia shuffleboard, and I'll be sharing these in a later video.
Well, I hope you enjoyed this video, and if you did, I hope you'll consider subscribing. As always, I want to thank you for watching, and come back and see us again. Okay, bye.